This sorts two students by score, and it works. But change one bracket and it silently sorts wrong. No error, no warning. Two nested loops just to rank a list, that's the real problem we are solving today. I'm Kai, welcome back to Fun with Learning Technology. Python gives you map, filter and sort it with a key specifically so you never have to write this loop again. Let's see why it's actually better, not just shorter. Before we fix that sorting mess, we need a tiny tool. Normally you'd write a full def block just to say what to sort by, name it, indent it, return it. A lambda is the same idea shrunk down to one line, an anonymous function you use once and throw away. In short, def is for functions you'll reuse and name. Lambda is for a quick one-off. Think of map like a factory conveyor belt. Every item passes under the same stamping machine and comes out changed. You hand map a function and a list, and it applies that function to every single item one by one without you writing a loop. Here's the trick. Map doesn't hand you a finished list right away. It hands you a lazy iterator, a promise to do the work only when you actually ask for the values. If map is a stamping machine, filter is a bouncer at the door. You give it a yes or no question and it only lets through the items that answer yes. Everyone else gets left behind. So filter takes a predicate, a function that returns true or false and an iterable and gives you back only the items where that test passed. Now watch what happens when we connect these two. First, the bouncer, filter, only lets through the items that pass our test. Then, whatever survives walks straight onto the conveyor belt, map and gets transformed. Nothing gets processed twice. Nothing gets wasted. It's one pipeline, filter first, map second, and the data just flows through it. Remember that ugly nested loop from the very start? This replaces all of it. Sorted takes your list and a key function that says exactly what to compare. Here, each student's score. No swapping, no tracking indexes. Python handles the comparison for you. Clean. Map keeps the same number of items. Filter shrinks the list. But sometimes you want just one final answer, like a running total. That's reduce. It takes two items, combines them, then takes that result and combines it with the next item over and over until only one value is left. You might wonder why you'd need this over a simple loop. Honestly, for a running total, a loop is often clearer. That's my honest opinion. Reduce shines more when the combining logic itself gets reused elsewhere. Two more tools worth knowing. Partial lets you lock in some arguments ahead of time and get back a smaller, simpler function. Ruka sits on top of a function and remembers what it already computed. So if you call it again with the same input, it just hands back the saved answer instead of redoing the work. In short, partial prefills cache remembers. I used to think Itertools was just extra sugar and skipped it for years. It's actually a toolbox for combining and generating iterators without ever building the full list in memory. Chain views sequences together. Count just keeps counting forever. And group B clusters neighboring items that share a value, but only if they're already next to each other. An unsorted list gives you scattered little groups instead of one clean group. So here's a fair question. If map and filter are so handy, why not use them everywhere? Because a list comprehension often reads more naturally. Filter then map, then look at that group by guess. Was it messy unless the list was sorted first? That's exactly it. Group by only groups, consecutive matching items. So an unsorted list gives you scattered little groups instead of one clean group. Now back to comprehensions. For straightforward transform and filter jobs, one line beats chaining two function calls together. One line beats chaining two function calls together, and this is genuinely my underrated pick of the video. So back to that ugly nested loop we started with. None of it was necessary. Lambda gave us throwaway functions, map and filter transformed and narrowed our data, sorted with a key replaced the manual comparisons entirely, and functools and itertools rounded out the toolkit for folding, caching and composing. It worked because each piece does one small job well, and they all snap together into a pipeline. One real limitation worth knowing, chaining too many of these can get harder to read than a comprehension, so use judgment not habit. I'll be back tomorrow with another one. Stick around, subscribe. If something feels off or missing, or you want to see something new, tell me in composing. It worked because each piece does one small job well.